Hello YouTube, this is Chester from STEM APKs. Welcome to another tutorial. In this tutorial, we're going to continue where we left off in the last tutorial. As you remember, in the last tutorial, we were able to create basically a PPM file, and I'd show you how to create them from scratch. But in this tutorial, we're going to be creating a binary file viewer. What that does is, this is an online version of what I'm trying to create. It allows you to uh, upload one of the images, like the image that we created in the last tutorial. So if you open it, it's going to give you the hex, and also is going to give you the equivalent ASCII characters, right? We saw that in the last tutorial. And what this allows you to do is then you can just copy and then bring it to another hex editor tool, and you can do all that good stuff. That's not what we're doing in this tutorial, which is cool stuff, but that's not what we're going to do. What we're going to do is create these, how to be able to view binary files, basically. And if I can show you now the code here that I have, and let me clear this so I don't want to confuse you. If I run the program that I'm going to show you how to write, if I run it on the same image that I use in her program, is the same image. So compare apples with apples. So we go, and there it goes. And you can see, if you look at her data, what you're getting from the online viewer, this is the same. P3 ASCII P3. 3 by 2, 3 by 2. Those are the dimensions of the image. 255, that's the max color value, which is white. The pixel data 00128, 00128. 850128, 850128. 1700128, 1700128, and so on. And you can do that. This is just for a P3 header image, a PPM, but you can also do it like she has it here for P6. Like, let's say this is the image that we created in our last tutorial. Let's do this one. We created that one together in the last tutorial. And of course, it's going to be more complicated because that's a P6, that's not a P3. And we went over the differences in the last tutorial. But basically, then you can copy and paste it and put it into this tool, right? Okay. Now, I'm going to show you. We also created a PPM reader for a P6 header. And that's what this code does. And there you go. And you can, and I'll show you, you can expand it to have more pixels and all of that good stuff, but we're getting to that. I just wanted to give you an idea of what we will be doing. I will be showing you how to create these files so you can have the same thing that she does here online, but you're going to be able to do it on your own computer. You're going to be able to browse the contents of a binary file or hex or equivalent ASCII characters. In this case, we're not doing hex yet. We can do it. Maybe if you really guys are interested, I can do it, create one for hex as well. But right now, we're just going to be doing ASCII and binary. Um, and you'll see it. This is binary right there. That's P6. But enough talking, let's get started. So let's go into the first one. Let's talk about the code because we're going to be seeing some of the things that we saw in the previous tutorials. Some of this stuff is new, so let's go over it. Basically, here we bring in the env. It allows us to access command line arguments via the arguments env from the standard library. Here, that's for the file handling functionalities. You saw it before. Here you have the buff reader. It enables the buffer reading, and the buff reader, this does it line by line iterations. Here's the main. You saw that something similar before. It defines the main function, has the error handling as well, and it's basically what it's doing is fetching command line arguments. And as you can see here, the if you know a little bit of C, C++, you remember that 0, it would always be the first argument, and so on. So actually here there's 2 that it's looking for. So it's going to be looking for the file and the the file name. In this case, for example, when we run it here, just want to make sure you don't get confused here. It's looking for the cargo run, no, binary, no, but it's looking for these and it's looking for that. And if it doesn't get those 2, it's going to complain. That's in reality, that's what's going to do. That's what it's checking here, there. And that's basically it. This, we saw that in the last tutorial. This is basically, it's going to be open in the PPM file here, and it's going to retrieve the file path from the command line argument, as you can see, and it's going to open the file path, and the operator, just the question mark here, is just making sure handling error handling. That's all it is doing. Then the buffer reader, it wraps the file in a buff reader, and it's more done for performance issues and manageable chunks. That's basically what's happening here. Here, it's reading the lines, line by line. It's returning an iterator, lines in the file. And basically, the unwrap, just in case it will complain. We've seen that before. It's basically to make sure that it extracts all the values safely. And that's what the result string is doing. As we continue going down, reading the header, the magic number, where else? I don't, before we get there, that's the header, the magic number. And now it gets into the reading the image dimensions. It's getting the width, the height, and what basically is doing is splitting. Well, splitting the white space. Is next unwrap basically is reading the second line because that's where the width and the height is found. Here's mapping. After it splits the white space, is mapping, and it converts each word into an integer. Basically, that's what's happening here. Here is collecting the parse values into a vector, this vector right there. And what else here? Just width, just basically extracting the width and the height. It's reading the maximum color here and making sure that it converts it from a string to an integer. And basically here is reading the third line, which is the one that contains the maximum value. That's what is happening here. Is printing, making it all look pretty. That's what you see when you see it there. Let me run it again so you see it. This is what's happening there. This is what you see. Here basically reading the pixel data is it creates an empty vector to store all the pixel data. It iterates. There's a for loop there that is iterating over the remaining lines that contain all the pixel values. It's splitting the white space like we saw there before. That's happening here, the mapping, and we talked about that just a few seconds ago. And it adds the parse values to the pixels vector. Here is it prints the first few pixels. You can control this. In this case here, I only have 10, but you can have actually this one. That's not the one. That's got a lot more than 10. So let's run the real one. Just run. No, it's not P6. It's P3. It's this one. So as you can see here, it's less than 10. But if you run the P6, it's going to have more than 10. For example, the noise PPM image, if we run it and we look at it, it's got more than 10. Where is it? It's right there. It's 20. And if you count them, you're going to count 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Yep. So that's what that is. That's where you can control, and that's in the P6. Basically, it's basically the same code, but once it's using the P3 headers, but this, yeah, I'm gonna show you it's almost the same. Actually, let's go into it because we're done here. So let's go into here. You can see all of it is the same. The only thing is here is a P6. It will complain if it's unsupported format. If it doesn't start with the header P6, it's going to throw this error right here saying complain and say that it's unsupported format. The dimensions, all of that is the same that we did before. Splitting the white space, mapping the strings for the parsing, collecting, and then creating those dimensions, extracting them. Reading the max color value, same thing that we did before. The print statements that make this happen right there. That's what that is. And same thing that we just did before. Where the chunk size and you control it like we talked about. And that's what's going on. And when you run it, you can even run it on more complicated images. This one is a synthetic image that we created, but let's do one that is not synthetic. And if you run it, let's do it again. Let me clear it to make sure that this is what I'm looking at. So go clear, then run it, and you can see the first 20. But if you change it here, let's make it 60 and save it and compile again. And there you go. You have a lot more. So you can control that. And it's giving you, remember, it's giving you the RGB values for each one of the pixels. And these images get really, really long, but like we talked about in the first tutorial, this could be very handy for certain applications. And now you are able to read the binary files right on your computer. You don't have to go online and do it. You can control it. You have total control of how you want to view your data. Okay, this is the end of this tutorial. If you like this tutorial, please click the like box, subscribe to my channel, and I will see you next time with another tutorial. Take care.